Okay, guys. So this is our last characteristic before we start transformations. We're going to talk about symmetry. And we're only going to discuss two specific types of symmetry, even and odd. Those are the types of symmetry we're going to look at. Even symmetry and odd symmetry. Even symmetry happens when the graphs are symmetric about the y-axis. Okay, so what does that mean? That means that you can reflect the graph over the y-axis onto itself.
The line's a little small.
There's some things in life you just gotta do.
Yeah, I guess you're right.
I think this is one of them. This is actually two.
Okay, so if I were to fold a graph down the y-axis, it would fold on top of itself. Does that make sense? That's called even symmetry. So that's if we look at it graphically. If we look at it algebraically, then this statement here must hold true. If we plug in the opposite of x into the function, we should get out the original function. And I'll show you in just a minute what that means. Now, the second type of symmetry we're going to study today is called odd. An odd symmetry is where we have a graph that is symmetric about the origin. And when it's symmetric about the origin, it has rotational symmetry. So what does that mean? It means you can rotate the graph 180 degrees. Around the origin onto itself. So first let's look at the graphs, because the graphs are the easiest and make the most sense. Here I drew in an example of an even function. I tried my very best to do a nice absolute value here for us. And you see I went ahead and put the vertex on the y-axis. So if we folded this graph on the y-axis, would both sides fall on top of itself? Yes. It has symmetry with the y-axis, therefore this would be called even. It has even symmetry. Now, the next one is just a line, but it's a line that I intentionally put through the origin because to have odd symmetry, it would have to have rotational symmetry through the origin. So if you think about the origin being like the little part on the spinner. Whoops. There we go, different color. Right there, like it's a little spinner right there. And I flicked it. And it spun. If it went 180 degrees, could it fall back on top of itself?
Yes.
Yes. That has rotational symmetry about the origin. It would be odd. Yes.
When you say reflects over the y-axis onto itself, if like you take this graph right here and you fold it right over
y-axis. Y.
Oh.
Yes.
Okay.
Now you got it. Okay. So even symmetry is a reflection across the y. Odd symmetry is a rotational symmetry, 180 degrees about the origin. Do those two things make sense?
Why can't you remember the x-axis?
That is not even or odd. Yes, you can. These are not the only types of symmetry. We could have a function that is symmetric across the x-axis. Would it be a function if it's symmetric across the x-axis? No, it would fail the vertical line test, wouldn't it? We can draw a graph that is symmetric to the x-axis, an absolute value that opens sideways, but it fails the vertical line test. We can also have graphs that are symmetric about other lines, slant lines. We can have graphs that have rotational symmetry around other points. But these are our two special ones we're looking at today. We're actually going to do rotational symmetries around other points.
Awesome.
It's exciting. We do cool stuff. algebraically versus a graph. Algebraically, all we're going to do is we're going to take and plug in the opposite of x and look and see if the function remains unchanged, or if the opposite of each term. If the function remains the same, we call it even. So if we plug in the opposite of x and we get the same thing we started with, it's even. And if we graphed it, it would be symmetric about the y. And if we took a function and we plugged in the opposite of x and we got the opposite, do you see how there's a negative right there? The opposite of the entire function. So opposite of each term. And that's the only thing that changed, it would be considered odd. Okay, I have 3 little examples here for us. And let's take at these. So I have f of x, g of x, and h of x. So if I took, this is my function f of x. If I took and plugged in the opposite of x, so instead of x in here, it's negative x. Well, what happens when I take the absolute value of something that's negative?
It's still even.
It becomes positive, doesn't it? So isn't this really simplified? This? So I plugged in negative x, and I got out the same thing I started with. Even. This function is even. Yes, sir.
Alright. I'm probably just isn't dumb here, but I don't know. Like, we have a horizontal line. The y is always equal. I just realized I said something dumb. Never mind, I'm gonna stop.
Alright. If you think of your question in a minute, you'd like to share it differently,
Like,
it's fine.
I explained myself by talking. Like,
Okay, you figured it out while talking. Alright, here's our second one, g of x. If I plug in negative x, alright, when we plug it in, we have to put it in grouping symbols. This one was already in absolute value bars, so I didn't need parentheses. This one has to go in parentheses because x was cubed, so when I plug in, negative x has to be cubed. Well, this leads us to a nice little reminder discussion. When we raise numbers, negative numbers to odd powers, are they positive or negative? Negative. The result is negative. When you raise a term to an even power, a negative term to an even power, is the outcome positive or negative? Positive. So here I'm raising negative x to the third, so I'm going to get out a negative x, aren't I? It simplifies to negative x to the third. And this is 5 times negative x. So this gives me negative 2x cubed minus 5x. Do you see I got the opposite of the first term and the opposite of the second term? I got the opposite of all my terms. If I get the opposite of each term, it is odd. So this one is odd. Now let's try this one. If I plug in the opposite of x, always put it in parentheses. Negative x cubed is negative x cubed. So negative x, quantity cubed, is the opposite of x cubed when I simplify it. So do we see how the first term changed and the second one didn't? So this would be neither odd nor even. It does not have symmetry to the y-axis, nor does it have rotational symmetry. It is neither odd or even.
Is this the only type of symmetries we'll be using?
Yes,
Or no?
right now. Okay? All right, so let's go back up here. This is even. It is symmetric to what if it's even? The y-axis.
Are we supposed to be drawing this graph?
You can sketch it. Just sketch it. It's fine.
I'll just take a quick sketch.
Yeah, quick sketch. Okay, it's a little hard for you to see, but I'm going to let you know what points are on here. The point 1, 7 is on here, and the point negative 1, 7 is on there. The point 2, 0 is on there, and the point negative 2, 0 is on there. It does not look like it from my graph. Let me draw my graph again. There we go. That's terrible. Poor Moby skills today.
Alright, you're better than most
It's
teachers.
okay, Miss
TBH.
Willoughby. We aren't
Okay.
judging you on your autistic
Thank you.
ability.
I appreciate it. And then here's one of my favorite functions, the polynomial that appears to be a W.
I didn't realize that.
Yeah,
It also looks kind of like a bonus.
Really? I don't think so. W. All the
Do you
way.
like W's because your last name is Willoughby?
Exactly.
I've noticed how she uses like Willoughby.
Matt didn't pick that up till now.
All the time. I am creative, aren't I?
You are very creative.
Alright, so if we look at this, if it's symmetric over the y-axis, if I go 1 unit this way and have a point, I have to go 1 unit the other way and have a point, don't I? If I go 4 units this way and have a point, then there better be 4 units the other way. Because if I fold it down the y-axis, it has to fold on top of each other. So for every point AB, so that would be in this, the opposite of AB must also be on the graph. Does that make sense?
Yes.
Because it has to have its mirror image on the other side of the y-axis. So if I do this in generic terms, if I say AB is on the graph, then negative AB must also be on the graph. So that's helpful for this next example. Here it's telling us we're starting off with an even function, and we have the points 3, 4, 2, 1, 0, 3, and 4, 0. What other points must also be on the graph? Okay, Matt, what do you think?
Negative 2, 1, 0, 3, and negative 4, 0.
Very good.
Thank you, I tried.
And this A here, it got halfway, but it would also be on there. So we would have to have the ones that are symmetric on the other side. So you can just count going the other way and list those on there. So if I fold it down the y-axis, they better all fall on top of each other. So my line of symmetry is the y-axis. Okay, so on the back, we have some odd ones. Now, these are cool because this first one is an odd one that doesn't pass through the origin. You may have been thinking it's got to pass through the origin to have odd symmetry. But do you see how on this one, if we thought about this being a spinner and we spun this graph, it would flip down here and this would flip up there.
Yes.
So even though it doesn't even pass through the origin, it still has odd symmetry. And the next one is a cubic function. It passes through the origin. It looks to have odd symmetry. So if I had done graphing this,
What you did.
I would have the point 1, negative 3, and also on the graph would be the point negative 1, positive 3. What do we notice about these? They're complete opposites of each other. So if we have an odd function, one that has rotational symmetry about the origin, it is symmetric to the origin, rotational symmetry about the origin. Then the opposites, negative A, negative B, would have to be on there. If AB is on the graph, then negative A, negative B would have to be there. Yes, sir?
On your notes, you spelled origin O-R-I-G-I-N and O-R-G-I-N. Which one is it, Willie?
It's this one.
Okay. Well, earlier you spelled it without 2 I's. Just saying. Somewhere.
Somewhere I did?
Yeah, because I remember. I was like, what?
Was it typed or something I wrote?
I think it was, I don't think it was right there.
There and there. It would surprise me. I'm not seeing it, but I'm not saying it's not there. Okay.
I just remember that.
Okay. Origin has 2 I's in it. Alright, so how would we show that this is an odd function algebraically? Well, if we plug in the opposite, we better get out the opposite. And we always put in parentheses. And if I plug this in, I get out negative 3x cubed plus 5x. Did my first term switch to the opposite? Yes. And my second term also switched to the opposite. So if I plug in negative x and I get the opposites of all the terms, then that algebraically shows me it's an odd, it has odd symmetry. It is symmetric with respect to the origin. Yes.
You put squared. That's not a 3 for.
Oh, you're right.
Catch there. That was almost bad.
Yeah. All right. So if we look at this, same type question as the even one, but this time it's odd. So since we know they both have to change, this is pretty easy. If we if we rotate it about the origin, that 3, 4 will move to -3, -4. The 2, 1 will rotate to -2, -1. The 0, 3 will rotate to 0, -3. And the 4, 0 will rotate to -4, 0. So we come over here and we graph those points. Now, this says what is the line of symmetry, and it's actually not a line. We need to fix that.
So
It is symmetric about a point, and it has symmetry with respect to the origin. Rotational symmetry about the origin. All right, number 5 we're not going to do because we did more examples earlier. Number 6 says complete this graph so that it has even symmetry. So that means I should be able to fold it over the y-axis. So what do I need? Show me, guys. Do I need the hump up or hump down? Even symmetry would be like this, wouldn't it? Whoops, no. It should actually mimic it really well, which is hard to do up here.
it's okay.
Okay, so that's somewhat even. Do you see if I fold it down the y-axis, I'm good? Make sense?
Yes, ma'am.
Yeah? All right, and odd symmetry. So this point, we have to be able to rotate it. It's way too tall. I can't do this on the maybe very well. That's better. A little bit. Rotational. Now, if you are not good with these and I ask you to finish a picture, all you have to do is like pick a point, like this point right here, and say this point was the point 2,5. Then what you would do is plot a point down here at -2, -5, and just kind of connect your dots. So if you're not good artistically, you don't see things. Some of us are good at different things. But if you can't just see this and finish it, then pick points and follow the rules that we talked about. Even would just negate the x. Odd negates both the x and the y. All right, now, if a function has neither even nor odd, obviously it wouldn't be symmetric to the y-axis or to the origin. Yeah.
If we don't draw it exactly but close enough, but
Yeah.
we take points off.
No, I won't take points off for close enough. If I can tell you were trying to mimic, just like I was trying.
Because it's the
The
thought
first
that
couple
counts.
tries didn't turn out.
I saw her this morning. She was singing and then I was singing.
Uh-huh.
And she was like dancing against.
Okay. All right, so do you see this does have rotational symmetry?
Yes.
This one? But the rotational symmetry doesn't occur about the origin, does it?
No, it
It would occur about a
Negative
point
2.
about right there where your horizontal and vertical asymptotes intersect. Okay, this one you might, if I had drawn it a little better, you would see it also has rotational symmetry, but not about the origin. It would be about a point here. So if it doesn't have rotational symmetry about the origin, or if it doesn't have symmetry about the y-axis, we would say it is neither.
All right.
Okay? Do we need to do these last two examples for you
Yeah,
tries?
that'd be nice.
Yes,
Okay, you try example 8 while I pass out your homework. And then I can pass out your quizzes, which I promised to grade, and I did.
Ryan, stop taking my pencil. Jack Willis. Jack Willis.
That is opposite of x cubed, is what that reads. So there would be a negative out in front, and then you would put a negative in parentheses, cubing it.
Any grade? Any grade, Ryan?
I'm going to have to check these desks every class period. I personally checked all the desktops the other day, and they're getting dirty again.
Mr. Weil writes all
I'm
over my
just going to have to
desk.
start doing that again.
Yeah. I believe Mr.
Should we
Weil
start
writes
telling
all
you
over
someone
my
wrote on
desk.
it so that you don't expect it to us?
Yeah, fine.
So I truthfully did it. It's someone said,
If you come in and there's stuff
Oh
on
yeah,
the desk,
somebody right there. I promise it wasn't me.
that's E. I can't get that off.
Oh, is it really? That's
Whoa.
Alright, I didn't want to see the graph, but when I tried to solve it algebraically, it just kind of like.
Okay, so let's go over this one then. All right, so this is f of x. So when I do f of negative x, this was the opposite of x cubed. So I have to do the opposite of negative x cubed. Well, this becomes negative x cubed, because a negative to an odd stays negative. But what's the opposite of a negative? Positive. So I get f of negative x is equal to x cubed minus 8. Do you see how the first term changed signs, but the second term did not?
Yes.
Is it even, odd, or neither?
Even. Neither.
Neither.
I was right.
If they both change, it's odd. If it stays the same, it's even. If only one of them changes, it's
Neither.
neither.
I don't understand that. What do you mean both?
We have two terms here.
No.
And the first term went from negative x cubed to positive, so it changed signs. The second term was negative 8, and it's still negative 8. So the first term changed signs. The second term did not change signs.
But when would the second one change?
They would. Okay. What our note said was, if it's the opposite of each term, every term has to switch to the opposite for it to be odd. And every term has to stay the same for it to be even. Otherwise, it's neither. So what are most functions going to be? Neither. Most functions will be neither. I have to specifically pick out special ones to make them even or odd. Like this one. This one is even, right? We plug in negative x. We get out x squared. Because a negative raised to an even power is positive. So we plugged in the opposite. Whoops, that shouldn't have a little 2 right there. We plugged in the opposite. We got out the same, even.
I'm gonna have to work on that.
Okay, good. Well, I got you some homework in which to have that practice.
Yes.
At this point,